Now that we're more comfortable with polynomials and multiplying polynomials, let's talk about factoring. And factoring is essentially the opposite of multiplying polynomials. It's writing a polynomial as a product of smaller polynomials, and these are called factors. And there are several different ways to factor things, and the way we're going to start is called the common factor. The common factor essentially just looks at what everything has in common and removes it using the distributive property. As an example, if I have 4x cubed minus 8x, well, 4 and 8 have a 4 in common, and we'll notice that both of these terms has an x. If I remove the 4 from 4x cubed, then my coefficient would just be 1, and if I remove the x, I'm left with x squared. If I remove a 4x from minus 8x, I'm left with negative 2, since negative 2 times 4 is negative 8, and then I remove the x. And you can go backwards to double check that this is right. If you were to multiply this out, you would get 4x cubed minus 8x. For this one, 12x squared y to the fourth plus 9x cubed y to the y cubed minus 3x to the fourth y. The first step is going to be our numbers, 12, 9, and 3. We can see that the biggest number that divides all of those is 3. As far as our variables, the easy way to do it is to pick the smallest possible exponent. For x, I have a 2, a 3, and a 4, so I'm going to remove the 2. The exponents for y are 4, 3, and 1, so we'll just remove 1. 12 divided by 3 is 4. I've removed both of my x's and one of my y's. 9 divided by 3 is 3. I removed 2 of my x's and one of my y's. And then I've removed the 3. I've removed 2x and 1y. We can expand this idea to some similar things like this, 3x times x plus 2 minus 7x plus 2. I can see that what they have in common is the x plus 2. So if I remove that, the first term is left with the 3x, the second with a minus 7. So I have x plus 2, 3x minus 7. Another example of expanding this, x minus 5 times x plus 7 plus x plus 7. I can once again see that they have the x plus 7's in common. So I can remove that. When I remove it from the first term, I'm left with x minus 5. And from the second, when there's no number in front, we're left with 1. So I can rewrite this as x plus 7 times x minus 4. My next one, x cubed minus 3x squared plus 4x minus 12. You may notice that all of these terms have nothing in common. There's nothing that every single term shares. So instead, we're going to use a different method called factoring by grouping. And essentially what this does is it breaks the polynomial up into two groups. And we factor there. The first two have an x squared in common. I'm left with x minus 3. The second two have a 4 in common, and I would be left with x minus 3. I can now see they have an x minus 3 in common, and I'm left with x squared plus 4. Factoring by grouping is a really helpful term whenever we have 4 different terms in our polynomial. Let's look at one more example. X cubed minus 2x squared minus 3x plus 6. If I look at my first two terms, they have an x squared in common. I'm left with x minus 2. For my next two, they have a negative 3 in common, and I'm left with x minus 2. So the reason I did a negative 3 instead of a positive 3 is because the sign on this first term is negative. If the sign would have been positive, I would have removed a positive 3. And now they both share an x minus 2. And I'm left with x squared minus 3.